I'm a practicing metallurgist from Institute of Science. I graduated, and day in and day out I deal with the corrosion. That's why I ventured to come and talk to you something about mundane problems which is faced by this thing. Okay. I will not take more than 10 minutes, Gopalakrishnan, so I will save your time. This is the common corrosion in the process industries, where you have got a uniform corrosion, where you can really gauge how much is going to come, etc. What is the life estimation is much easier. This is a non-uniform corrosion which may cause very catastrophic failures, a variety of this. And you have chemical corrosion. That is where I'm going to talk basically. When you talk about the chemical corrosion, it's a process industry. What is atmospheric corrosion, whether it is generally in the outside atmosphere or in the process industries, variety of corrosion taking place. See, primarily, corrosion follows our Rigveda. Everything has come from earth, everything goes back to earth. In between, you do some circus to bring it out and do that, including human being. Okay? That is what it is. So, my professor Krishna, I don't know if you remember him or not, used to teach me corrosion can never be stopped. It can only be stifled. I don't know whether Professor Raja's time it has been changed or not, I don't know. Okay. And many of the corrosion is basically oxidation, essentially. And you have a high temperature corrosion. See, in the whatever the morning we talked about, other than the petrochemical industry, we talk about the oil in the exploration, etc., your corrosion environment can be predicted by and large. You can think about it, what is going to happen. But in the chemical industry, that sort of a prediction is highly unlikely, because the number of variables are very, very high, and the types of reactions are very high. Temperature variation is very high. So the temperature plays a very important role. I will just touch upon that. And when you talk about the offshore and the ongoing vessels and all, basically water corrosion, and all those things are basically classified in the electrochemical areas. The uniform corrosion is very well predicted, but when the pitting, it can be caused by the various reasons. Maybe segregation of the material, or maybe some other thing. This sort of actions is taking place. Crevice corrosion, selectively leaching, etc., intercanal corrosion that we have studied very clearly, where the stress corrosion cracking. See, wherever the corrosion is taking place, thermodynamically it should be feasible. Why the intergranular corrosion take place? Because there your entropy is different. That is why it is happening there. Stress corrosion cracking. These are all what we have studied, corrosion by fatigue. And another major problem is hydrogen embrittlement. Why I specifically talk about hydrogen embrittlement? We talk about the cathodic protection very liberally. Once you increase the voltage, the hydrogen comes there, and that can damage the system basically. So that's why I'm specifically talking about hydrogen embrittlement. And many of the water treatment plant where inadvertently hydrogen comes, that causes a corrosion basically. And erosion, wherever you handle the slurries, chemical slurries, the erosion is more. See what happened? As we all know, in the metallic corrosion, once it forms a coating, the corrosion resistance is established. But once you have the counter velocity and erosion, it keeps on removing the coating. So the fresh material is being subjected to the corrosion. Corrosion outcome can be very aggressive, and the life of the equipment could be pretty short and unpredictable basically. And biological corrosion. This is more important basically because the cross-country line goes through various areas where many places, in fact I visited a number of the the pipelines, you see all are cathodically protected, but here it got damaged because that goes to the slum area. So many biological corrosion take place, and this terminology we never studied during our time. Now it is very, very prevalent, and it causes a real problem. And electrochemical corrosion, galvanic corrosion, which apart from the process industries, electrical industries also talk about galvanic corrosion. Very interesting. Many of the electrical instrumentations, failures, etc., talking about. And then the electrical engineers come and talk about EMF series. How not to go for two different highly dissimilar materials. They talk about it. And this is the one interesting chart with the various difference of materials. The green area, if you contact this thing, then you will not have any galvanic activity. The red one will have. Now I'll come to the corrosion process industries, how it can be controlled. In the process industries, when I say process industries, a variety of acids, alkalis, various temperature, this sort of a thing is what is going to happen. The following are the methods what you have, probably a choice of material. When you get into the process industry, the simplest material you talk about a metallic is stainless steel of various grades, not your plain carbon steel and other things. Isolation of the material by coating or plating or trapping, etc. And using corrosion inhibitors if it is the flow the material is there, and galvanizing and surface finishing. Electrochemical methods by cathodic protection. These are all the 5 solutions available to you for any corrosion protection activity. Now, coming to the choice of materials, what all do you have in the process? See, when I say the process industries, typically what? In India, if you take about fertilizer industries, pharma, metallurgical, and water treatment plants, dyes and chemicals, chloralkalis, these are all the typical process industries what you come across that. So you have a wide choice of material for the both metallic and non-metallic. Metallic materials, you got a variety of stainless steel, maybe ferritic steels, martensitic stainless steel, austenitic stainless steel, the various SS316, all the 300 series, and duplex steels. You got a super duplex and other thing wherever you have got a chloride environment, this thing. Super alloys like Ninconal, alloy 20, and nickel, this sort of a material. These are all the things what you use in the, and variety of bronzes, exotic materials like titanium, tantalum, etc., typically in the process industries. And you have a choice of plastics, starting from the simpler application from PVC to the polyethylene and ultra high molecular polyethylene, PEEK, and a variety of polymers like PVDF, PTFE, PFA, PFEP. See, in the reducing atmosphere wherever it is, or the chloride atmospheres, non-metallic material can be comfortably used. That gives a good solution. And those days we did not have the modern polymers, particularly the fluoropolymers those days. Now variety of fluoropolymers are available, which can be operated right from the ambient temperature up to about 280 degrees centigrade. It can withstand variety of acids, both oxidizing condition, acidic condition. This has replaced many of the metallic materials. See, when you have a limitation with the plastics, wherever you have a corrosion with the aggressive erosion, the plastics cannot be used. So you have to go back to the metallic material, or wherever the temperature exceeds more than 300 degrees centigrade. See, in fact, in the process industries, you may go up to about 850, 800. See, we supply number of pumps for a molten caustic soda, and to the BARC group, the molten zirconium chloride pumps are all going to very high temperature. So the corrosion as well as the temperature resistance and the mechanical stability, all those things has to be considered basically. I have listed typically various chemical industries. See, for example, if we talk about fertilizer industry basically, you have a DAP, diammonium phosphate, and superphosphates, etc. Basically, you have a sulfuric acid and phosphoric acid. The way hydrofluoric acid, HF comes as a effluent, so you are the scrubbing of the hydrofluoric acid. Why I specifically talk about HF is no metallic materials can really withstand HF basically. So you have to look for a highly corrosion resistant non-metallic material which can withstand some amount of temperature. And interestingly, the hydrofluoric acid scrubbing, hydrofluorosilicic acid scrubbing is required for all the fertilizer industries basically. So essentially you have one material, ultra high molecular density polyethylene, because it has got a high slurry resistance and high corrosion resistance. And fertilizer industry, some of the nitric acid, because the fine soil nutrients are nitrogen based. So these are all the acids what you have. If you come to the pharma industries, basically most of us know that either pharma will be chloride base or sulfur base. And you have the handling pure acids is easier, but it comes along with the solvent. So you can't go for the metallic materials. So solvent with the thing, you go to special plastics and metallic materials. That is a typical problem of the pharma industry. So pharma industry solutions are totally different from the fertilizer industry solution. You have a select about 10 different materials of construction, that matter is over. Same way the metallurgical industries, like a copper or a steel or a zinc, hydrochloric acid, this sort of a thing. And you've got a pickling area. So this is the typical various acids comes. Metal treatment like hydrochloric acid, chromic acid, cyanides, and copper sulfate, they're all basically there, and all only metallic materials you typically use. Chloralkali industry specifically I'm talking about. That is where you talk about the chlorine and hydrochloric acid. A lot of titanium is used for brine handling, which normally other units are not. The regular process industry, only with the chromic acid industries, a lot of titanium is used. So for running a process industry, basically open a corrosion handbook. Keep on referring that, okay? Keep on referring that. And there, one more thing you have to know is the chemistry is important, whether it's the oxidizing condition is prevailing or reducing condition is prevailing, or alternatively this is happening. If it is simple oxidation, you can select a material easily. Reducing condition, whether the temperature, the reaction, that is a challenge comes basically. And another area is the dyes and specialty chemicals. It got a variety of acids, and a lot of slurry handling is there. There, typically variety of non-metallic materials plays an important role. Petrochemical industries, morning people have talked about. Sea-going vessels. The sea-going vessels, apart from the corrosion of the seawater, you have a lot of the organic materials. That gives you, somebody from the NMRL is here? Somebody was NMRL, anybody here? See, they specialize in this activity of, we interact with them quite closely to various suggestions for the naval ships and all. There, the corrosion problem, how many minutes over? I'll finish it now. So that others will get more opportunity. Typically, so all the seagoing vessels, you've got two different areas. I'll just, one is your cathodic protection, primarily used and to ensure just adequately protect, don't overprotect it. So the hydrogen embrittlement problem can be avoided. Now, the seagoing vessel, one more issue is there. The cathodic protection, the current passes, that creates a electromagnetic signature. So Gopalakrishnan should become. Now, the enemy will have the picture of the electromagnetic signature, and he will trigger his mines based on the signature. So now in our naval ships, from the regular cathodic protection, alone, you shift it to another area where you have all sorts of this sort of a signature management. That also comes into picture. So it is no metallurgist will ever know this area, right? So it is a very typical area, particularly for the naval ships. Probably the commercial ships also, because you have the many Houthis and all those people are there, Yemenis and all. So that is a very interdisciplinary area where a lot of modeling and predictions, and you have to validate that. One more area in the ship comes, the ship goes into seawater, and you need the water to drink. And not only that, the ship has got so many water pipelines. So the alkynes will go and block it. So you essentially require anti-fouling and anti-corrosion systems. See, Professor Raja may agree, for the water, anti-fouling, the two, our grandma's answer is there. One, use a silver cup or copper cup. Those days, why they have the copper ion and silver ion, they are deleterious to the marine organism, good for the human being. So you have another system, both the naval ship will have anti-corrosion, anti-fouling system also. So these two has to be integrated basically, right? So that is a typical area of the naval ships. And you have the explosive manufacturing, variety of nitric acid at various temperatures, various oxidation, this thing. Water treatment plant, nitric acid is there. Nuclear area. The nuclear area, basically the corrosion can be well predicted. And the only thing, they have so many qualification. Morning in PCL, somebody came, they all come there. So we supply a lot of pumps to them. So only thing, they have got a various qualification like IGCC test this, etc. Do that. And you can be very comfortably can predict, yes, this is a lifetime what you are going to give. See, when we talk about the pumps, we say, yes, when we talk about the high value pumps, we say this is the corrosion allowance. For this area, this so many years we guarantee, right? So it is well predicted and can give it. Unlike the commercial small pumps where you just pump the water and be done with that. Here you can't do it, you just qualify it very clearly what it is basically. And I talked about the material guidelines. Basically, whether you got an oxidizing condition or so and so acids, select that basically. Open a simple, that corrosion guide handbook even now is useful. Right, okay? And you have to understand the chemistry behind what system is going to go happen. And see, if you talk about the materials, variety of materials, all only for process industries, high silicon iron, alloy 20, Hastel IB, Hastel IC, titanium, R55, 350. These are all the typically only for chemical industries. Non-process industries, you will not hear. Am I right, sir? In the other area, you will not hear all these materials. So please go through the data of all this and suitability of that, and you can comfortably run the process industry, because process industries got a temperature variation right from minus 200 up to about 1200, 1300 degrees centigrade variety. Variety of oxidation reactions, variety of reducing reactions, and it is not a predictable constant reactions are not there. Material selection, variety of these are all the materials. For example, if we talk about 3D forum CU, other area you will never hear that. Alloy 20. See, particularly I want to talk to you about the fluoropolymer, various temperatures we have got. About 20 years back, we did not have any one of this material, right? This has replaced many of the metallic material in the process industry, make their life simpler now. And corrosion, variety of corrosion inhibitors are used wherever the liquid type of corrosion is there. Vapor phase inhibitors and the liquid phase inhibitors are there. Cathodic protection is basically wherever you have got a electrochemical corrosion, cathodic protection, mostly for the pipelines, tanks, heat exchangers. variety of this thing. You know, the cathodic protection, typically we use the magnesium, zinc and aluminum as a sacrificial anode, or the impulse current, various anode, special anodes like mixed metal oxide anode, platinized titanium anode, etc. In the heat exchangers, you may know, the incornal heat exchangers, the sacrificial anode is iron. I'm just telling you. See, the iron is a sacrificial anode. There is no need of going for a high very exotic, nothing. Simple iron is the anode. That will protect us. See, the advantage of cathodic protection is this is the place where you can measure, sitting in your office, measure where the corrosion is taking place or not. Against copper sulfate 850 millivolts, if beyond that it is protected. It can be sure, measure it and be done with that. So, you know, at various places wherever you have to give the reference electrode, maybe in the case of pipeline, maybe in the case of offshore structure or this thing, so that you design accordingly and be done with that. And now number of modeling experts have come there, where to place it, what to place it, etc. and make you can validate that modeling whether it is okay or not. So, cathodic protection is the easiest, if wherever the electrochemical corrosion is there, think of a cathodic protection. See, our old the galvanizing also basically cathodic protection only. So, the electrochemical corrosion behavior is totally different from the other forms of corrosion. Here you need a electrolyte, maybe soil or maybe any liquid water, and you need an anode. See, wherever it is anode, corrosion take place. Wherever, so you convert that into the cathode. That is the cathodic protection principle. Probably this is what I have given this in pictorial references. And some of the process industries, anodic protection is also used. That is, wherever you got the stainless steel, you get into the passivation level, the higher level at the critical point, so that the corrosion does not take place. Very simple mechanism. You don't need to go for an exotic material or any coating. Very simple solutions. Non-metallic coating, morning many people have talked. I don't want to dwell on that. Especially the coatings, somebody else also talked about it, so I'll leave it like that. Corrosion control by surface modification. Maybe you got a phosphatizing, the siliconizing, anodizing, chromatic films are there, chemical corrosion. So, corrosion control surface is typically, this is the variety of this thing we face in the process industries. Process industries corrosion is totally different from the other area. So, I thought let me just give you a flavor of that. It is what I talk to you is a very mundane thing, not a scientific one. Thank you for that. Thank you for that.
Have some. He said that in the mundane position there was a wealth of information that many of us doesn't know, and very thankful.
Hey, don't give me a flattering word.
I'm just saying. At least for me, I'm just. One question. Anybody?
See, nobody has got a question. Don't worry.
There is a question.
What is that?
You said iron is used as an anode.
Yeah.
Yeah. So
Simple iron, high purity iron for all the heat exchangers, wherever the incornal heat exchangers are, use the iron as anode.
okay. So
Pure
are
iron.
there any specifications available?
Yeah, specifications are there. I can send it to you, right? Okay.
Thank
It's
you.
being used also. See, now fortunately for everything you have got a specification. ASTM you have got everything. NAC, master of NAC is available. See, I will tell you one more thing. See, I am the national chairman of the ASM International. Okay, with it. I am trying hard in line with the increasing self-esteem of India. Why should we still depend on the NAC qualification, NAC certification and all? Can we not develop our own qualification? Can our, see, one of the people who have been talked about is Engineers India. They always believe a Western thing is much better. There are a lot of brilliant brains available, originated from the institute itself. We can develop many standards, many testing procedure, many qualifying things, and this organization like Engineers India should approve that instead of cherry picking the various this thing and coming out. So there are now fortunately the standards are available to everybody. It's a wealth of knowledge. If we can categorize it, and many of this test qualification and simple procedure can be adopted. See what happens, especially in the corrosion, many people after retirement they become corrosion experts. To make money they give a complicated solution, right? Okay. See, I see every week at least 2 people come into my office. I said, I give a classroom lecture. Okay, I said, don't give me. Saraswati is not for sale. Okay, Saraswati is to be shared. Right? Okay? This is what we do, and so I thought I answered your question, isn't it? Right.
So thank you. So thank you very much. Let's give him a big hand. And as he said that these standards from the Indian industry point of view is very important. And I would request INSIS, which is a Society for Structural Integrity, to take this up. And I am the Senior Vice President, and I will put this as one of the agenda. And we would require your help to generate these standards, because what you say is 100% true.